Hello, here we are in the testing place for the battery clusters. On the back of my side, you can see there are two battery clusters. Each of them are 186 kilowatt hour with 13 models, and here is a highway box. And the battery models connect each other with the positive cable and the negative cable, and also the communication cable. Finally, it will go to the highway box. These two input and also the communication part. Then the highway box will output the DC high voltage and also the communication information through this cable to the inverter. You can see this 3 cable, 2 power cable and 1 communication cable will go to the inverter. Then you can see inverter, there are 2 input of the battery. This is one battery cluster, this is another one. And we are using this inverter connecting battery and also the grid. Here the 2 cables are communication cable for the battery clusters. And that 3 cables, this 3 cable will go through here. Finally it will go to the grid. Then this is the grid breaker here. So we are using the grid as a charging source to charge the battery to be full. Then after that, we will discharge the battery to the energy to grid for the discharging process. So here is the process, how we do the charging and discharging for the battery clusters. Okay, now we are going to have a look how we do the discharging process. Firstly, let's have a look at the battery status right now. The SOC is 99.4%. The voltage is 695 voltage, and also on this screen you can see the cell voltage. You can see all of them. This is like each cell, and also each cell the temperature, and the other like the relay status, and also other information. So here is HMI for the battery operating and maintenance. So right now it's 99.4%. Then this one the same is like 99.5%. the SOC. So it's almost full. Now let's have a look about how we set the inverter. The inverter, you can see, firstly, right now in this time, today the buy, it means the get energy from grid is 123.2 kilowatt hour, and the sale is like is sending the energy to grid is 1.4 kilowatt hour. So we will record this number, and then we start to do the discharge. So right now let's do the setting to discharging in 50 kilowatt. Yes, we are going to set the max discharging current to be 100 ampere. Now you can listen the relays to turn on in the inverter. Right now it's going to discharge. You can see the power flow from the battery to the inverter. And in the middle you can see this is on. This here is the power flow from the battery to inverter. Then you can see also the battery SOC, so 99%. Let's wait a second, then it will, let's see how much the power it will reach. Now it's connecting to the grid. Then you can see the discharging power is increasing to 0.16 kilowatt, 4 kilowatt. We are setting to be 40 or 50 kilowatt. So it will reach that number to discharge the battery fastly. Okay, also we can have a look at the SOC and the battery screen. You can see this right now it's discharging, it's 27 ampere. It's reaching, if you use this 29 times that's 700, it will be around 22 kilowatt. And also let's have a look another one. The discharge current is already 32.8 ampere, and the voltage is 688. So the voltage drop a little bit and the current is increasing. So let's have a look at how much it is on the inverter. It's like 40.8 kilowatt. So we are going to keep in this power for maybe 2 or 3 hours. Then let's see how much energy it will discharge and how will be the SOC. Now after 2 or 3 hours, let's have a look how much electricity the battery cluster discharge. This SOC is 68.1%. This one is 68.6%. We can consider 68.5%. In the beginning it was 99.5%, so we can consider it discharges 31%. And now let's have a look how much energy it sent to the grid. It's 118.1 kilowatt hour. So let's make a calculation. In the beginning it was 1.6. So totally it discharged 113.5 kilowatt hour. And then we consider the efficiency of inverter to be 98%. Then actually there are 119, almost 19 kilowatt hour energy from the battery. And then we consider it discharge 31%. Then this is like 383 kilowatt hour. Then we divide the two clusters. So each cluster is like 191 kilowatt hour. And in the beginning, our design is 186. So it's like 3% higher than the rated power capacity. So it's positive, like 3% positive value, okay?